chemistry. Organic chemistry, little bit you have already done in school. Okay. And preliminary you have done in school. So here in class 11 also we are not going to do in such a exhaustive way. Only introduction of the organic chemistry will do, and we'll try to understand that how does it differ it from the inorganic chemistry. All right. So I'll start now. See, first of all, if you compare the inorganic chemistry or inorganic compound, the organic chemistry or organic compound, you will find inorganic chemistry has a very long history. In fact, with the inception of human civilization, people could try to get information about different things which is there present in the surface of the earth and their utility. And most of the things were nothing but from the inorganic chemistry. Then also, basically, you can classify the chemical compounds on the basis of their source, that is from where we gather it or we get it. We can either get it from the inanimate objects. It may be present in the surface of the earth or present in the atmosphere, or maybe that you get it below the surface of the earth. Lifeless. So inanimate sources. And other substances, we got it from the living sources in the form of plants and animals, including human beings. So the substances which you derive from the living system, means organic, we are being labeled as organic compounds. And those who derive from the non-living sources, we classify them as inorganic compounds. So, as I told you, when the evolution process, in the process of evolution, when we could establish the existence of the human being, when they have enough ability to understand what is available around them, how to use them, how to multiply them. Okay, from there, the concept of chemistry started. Not only concept of chemistry, concept of science started. See, earlier, people were nomadic in nature. They used to move from one place to another in search of food. And in most of the cases, the food they used to gather either by killing animals or they used to get it from the plants around them. They did not know how to cultivate. So in order to gather these substances, they required some sort of weapons. So initial civilization started with, we called it the Old Stone Age. So those equipments or the instruments were very, very blunt. They used to make it from the stones or rocks. Gradually they could find that with the blunt object, it was difficult for them to hunt. Then they have learned how to make them sharp. So this from here, the new Stone Age has started. Till now, in different places, by digging some places, people could find the existence of the new Stone Age. Then, interestingly, after new Stone Age, people could move to another stage where the use of the metal have started. So the third is called Bronze Age. That is, from there we could understand that people have learned to use fire. Because without use of fire, you cannot get metals from its ores. Okay? And then they have learned how to make fire. And this is an indication that people started settling down. And as it was very difficult to create fire, so they used to harness this fire in some caves. And by this time, people have learned also the art of agriculture. Then they started settling down. Basically, they used to settle down from the sources where they can easily get water. So most of the civilization has started nearby the river or any other large water bodies. It may be in the plains area, or to avoid the invasion of the enemies, they might have settled down in the hilly areas, but where water was still available to them. Bronze is an alloy. We know it. Bronze is an alloy. Then people, after this Bronze Age came the Iron Age. By this time, people knew how to make all different types of the implements required for agriculture and for some other purposes. So from those days itself, the inorganic chemistry started into existence, and gradually people could discover and knew how the art of extracting different metals from their ores. It was not that organic chemistry was not studied. Yes, it was there. But most of the organic chemistry in those or compounds people could use only in the form of medicines. But it was not exposed to the general public. Because in every society, one or two persons were, they knew that utility of the different parts of the plants and how to use them as medicines. And they were only restricted to either one or two families in the society. They were extremely powerful. Most of them, they belonged to the priest. Even the king also was afraid to antagonize them. So it remained only in the family. And in the families also, when it went by the generation wise. So large scale knowledge of the organic compounds were not known. It was hardly 400 or 500 years back then people started learning about the utility of the organic compounds, and they were always being gathered from the plants, and they knew there is some supernatural power which creates this organic compound, and people cannot make it. So that theory was called vital force theory. Okay, so they knew only from the living sources organic compounds can be extracted, but gradually, by the beginning of the 19th century, people started doing a lot of work in different workplaces, and they could prepare some organic compounds from the inorganic sources. Okay. some of the examples which I can tell you, which we have done also, like people could make acetylene by the action of water on calcium carbide. Don't write. Similarly, by addition of water to aluminum carbide, people could make methane. Okay. Then a famous discovery was that if you heat ammonium cyanate, if you heat it, they could get urea, which earlier people used to got it from the urine. Then they started believing that no, it is not the question of the vital force theory. Even organic compound can also be obtained from the inorganic compounds. So they have redefined the organic chemistry. That is organic chemistry is the chemistry of carbon. Okay, that is the compounds made of carbon are organic compounds. Okay, but exception is also there. Or compounds of carbon need not be organic compounds. What are the exceptions? Like you have bicarbonates. This where this is there. Carbonates, where you find compound containing this. Then metal carbides. These are metal carbides. Okay. Metal carbonates. So these are, except this, rest of them are the organic compounds. All right. So you can write down this. জল সকালে খুলে কিনা কোনো ঠিক নেই see there are altogether till now we have 118 elements are being discovered. 118 elements are discovered. Out of 118 elements, only for carbon a chemistry is being devoted, where rest 117 we study in inorganic chemistry. So what is the speciality of carbon? So can you tell me? Piper moila jao. What is the specialty of carbon? একটু জল ফেলাই দো ধরো আমি ফেলাই
Fractionation.
Yes, very good. Specialty of carbon. It is catenation. And third is the second. It can have carbon-carbon single bond, carbon-carbon double bond, and carbon-carbon triple bond. This is the specialty of carbon. All right. So, catenation, you know. The property by which they can form chain. Okay. Thousands and thousands of carbon atoms can join with each other. Example, graphite. Example, diamond. Though we classify them as inorganic substances, but they have this ability to form chain. And you can also find organic compounds where 70 carbon atoms are joined with each other. Okay. Example, not only 70, more than 70 also. Example is fullerene. These are synthetically or man-made substances where you find even fullerene containing more than 100 carbon atoms are also being prepared. All right. So this is the specialty of carbon. All right. Now we'll go for classification of organic compounds. Classification of organic compounds. All right. So right now here, organic compound. See, organic compounds we can broadly classify into two categories, where the chain is being forming. In one case, it is open, and second case, it is closed. Okay. So we can write here now. We call it acyclic. That is, we can call it open chain. And we call it cyclic. That is closed chain. Now, acyclic compounds can be again classified into two categories. We call it saturated, means here there is no double bond or triple bond. Okay. Only single bond. And here we call it unsaturated. It is contains triple bonds. Okay. Here you will find these are called alkanes. Or its derivatives. Here you will have, again, this will be again classified into two categories. They are called alkenes and we call them as alkenes. Okay, it is carbon-carbon, double bond, and its derivatives. Here you have triple bond, and its derivatives. Right up to this, I have to rub this board. Oh. Okay, now we'll go for cyclic compounds. Okay. Cyclic compounds. Cyclic compounds again can be classified into two categories. One you call it carbocyclic, that is in the ring, or the ring is being made by carbon. And this is called heterocyclic. Please remember, organic compound is made of carbon, and other than carbon, you have plenty of hydrogen. Okay? But in the ring, any other element except carbon and hydrogen is there. This is called, these atoms are called heteroatoms. So we call it now heterocyclic. Okay. Now, carbocyclic compound again can be classified into two categories. We call it aliphatic, and second one you call it aromatic. I'll discuss everything with you. Aromatic. Now, when you go for aliphatic, okay, then I'll give an example of, okay, let me write aromatic, then after that I'll perform. Now, aromatic can again be classified into two categories. Okay, we call it benzenoid, and second one we call it non-benzenoid. Benzenoid means these are the substances which contains 6-membered ring. This is benzene. Okay. Then say this is, it contains 2 rings. Okay, we call this one to be anthracene. So these are all benzenoid. In non-benzenoid, they are aromatic, but they do not have 6-membered rings. Example, this is called cyclopropynyl cation. This is 7-membered ring. This is called tropolone. Okay, now aliphatic, you'll find it 6. It all the places, see, here I did not write anything because all these joints are having carbon. All these places carbon is there. Other than carbon, we have hydro. Okay, I'll write down carbon. So now we will not be accustomed to this. Just see here. Here also you have hydrogen. I don't have misplaced to write. Sorry. Hydrogen. This is called cyclohexane. And in all these places you have carbon. Valency of carbon is 4. So here also you have carbon. Benzene. Here also have carbon. Here you don't have hydrogen. These two. Hydrogen. Okay. This one I will write separately. Otherwise, it will be difficult for you to know. My handwriting is also not good. Okay. This is called propolone. Now, heterocyclic compound again can be classified into two categories. These are aliphatic and aromatic. Okay. Aliphatic, you'll come across this is called pyrrolidine. This is called tetrahydrofuran. This is called piperidine. In aromatic, you'll find this. This is called pyrrole.
বাচ্চাকে যে রাখতে বলেছিলাম তুই রাখুনি, তখন আমাকে যে বললো তুমি সরো তাহলে রাখবো।
আমি তো আমাদের বুঝছি না, আমি আমার ইউরান is called pyridine. Look, don't get scared by this molecule. You will be able to, after a few days, you will be able to name them also. Now the question is that, how do you write these organic molecules? What are the way we write the formula? Okay. So, writing the formula or structure structure of organic molecules. You know now, methane. Methane formula is CH4. Ethane contains 2 carbon and 6 hydrogen. Okay? So methane we write like this. We write here CH4. Ethane we write C2H6. Butane we write C4H10. Hexane H14 we write like this. From when you write like this, you have no idea how does it look like. So let me write hexane here. Say it is here the carbon, because organic chemistry we know they are being joined with each other through carbon. Chain is always being made of carbon. Okay. Now this. When you write like this, then you have full-fledged idea how does the molecule looks like. But when the molecule becomes bigger and bigger, then it becomes really difficult for us to write because it takes a lot of time. Especially in exam, it will be difficult for you to write such a long molecules. Okay, and by mistake, if one of the carbon is missing, then your formula has changed. So this is its actual structural formula. This is the structure. Okay. Say here I have taken benzene. Benzene is C6H6. So this is the structural formula of hexane. Okay. Then just now I have drawn the structure of benzene. This is the one. So now, if you want to write it short, what should you do? See here. In this molecule, at the beginning, we have a carbon with 3 hydrogen, and at the end, we have carbon with 3 hydrogen. Okay, these are called methyl. And see, rest of them is having CH2. Here you are having now CH2. This is called methylene. Okay. Now, how to write it short? We have found between 2 methyl, you have 4 CH2 groups are there. So I can write this one in this way. CH3, CH2, 4 are repeated. I can write it like this. Okay. See here, in this benzene, every carbon has 1 hydrogen. Okay, how many carbons are there? 6. How many hydrogens are there? 6. We write here C6H6. So if anyone writes C6H6, after a few days you know this is nothing but benzene. You will also know that this is nothing but hexane. All right. So this is called condensed formula. We can write big molecules like this. Say I have taken here. Okay, we know it is hexane, and this is benzene. Similarly, you will find here C10H8. After a few days, you yourself will write. It is called, sorry, dear. This is called naphthalene. So these are the condensed formula. Okay. Say you can have a molecule with this CH3, CH2, 10, CH3. This is called dodecane. Okay, see, a derivative of dodecane is nothing but we are using it in the form of soap or detergent. You have seen the molecules which I have written, in which every carbon is joined with other carbon, and rest of them are nothing but hydrogen. So when it is so, say this formula, I can write it in this way. I can write it in this way. This hexane can be written in this way. So this is called bond line structure. It is, we have already drawn the bond. From there you will be able to know. After a few days you also will write it in this way. See here. Here, let me expand this. Every tip, and these are called bridges. Are made of carbon. So I'll write here now. C. Okay. Now we know the valency of carbon is 4. Valency of carbon is 4. Okay. And each bond is a valence. See here, here, all the valence of carbon is 4. Here, you have one bond. Means rest of this valency are being satisfied by hydrogen. So it is 4 minus 1. So it is 3. What should I write now here? See here, 2 bonds. 4 minus 2. So here it is 4 minus 1. See here, 4 minus 2. It is 2. It is, I will have now here. See, 2 hydrogen. Here also it is 4 minus 2. It is 2. So I will have now. Here also 4 minus 2. So it is 2. So I will have 2 hydrogen.
Sir, excuse me, sir.
Yes.
So I don't understand the bend line structure.
Which structure? Bond line.
Yes, sir.
In bond line structure, we do not write any elements. That is, we know that organic compound has to be a compound of carbon, and other than carbon, you have hydrogen. Other than carbon, you have hydrogen. All right? Huh?
Yes,
so,
sir.
this is the one I have written. How many carbons are there? 1, 2, 1 and 2. Sorry, 1 plus 4, 5 plus 1, 6. So I've written here now 1, 2, 3, 4, 5, 6. Now I am developing this one. Okay, suppose you have drawn a sketch. After drawing the sketch, what you do? Then you try to put hair on the head, you put eyebrows, you put the other features are there in the face. So here also, because we know that every person's head hair is there. In everybody's eyes, eyeballs are there, eyebrows are there. Is it not? But different sketches looks different when you start putting them. So here also, we know every organic compound is made of carbon. And the carbons are joined with each other because of their property of catenation. So I have now joined them with bonds. But here no elements are present. But we know in every linkage, the linkage is being made of carbon. See here. So I have put on carbon here. So this carbon is joined with another carbon with a bond. So this is the one. Here also you have carbon, here also you have carbon, here also you have carbon, here also you have carbon. So I have drawn with carbon the skeleton. Then what rest are there? Rest are nothing but the hydrogen. How to know how many hydrogens are there? For that we know carbon irrespective of any compound, valence is always 4. And every bond is being formed by satisfying valency. See here now. Between these two carbon, you will know only one bond. So I have written 4 minus 1, that is 3. That is, this carbon, rest 3 valencies of this carbon are being satisfied by hydrogen. So I have put now here. Here you have 2 bonds. So 4 minus 2. So this carbon has 2 hydrogens. Similarly, this also have 2. This also have 2. This also will have, see, 4 minus 4. Valence of carbon is 4. And these are the 2 valency I have subtracted. So 4 minus 2 is what? 2. That is, you have now 2 hydrogen. In this carbon, see here, only one bond is there. So it is, what will be the rest of the valency? Rest of the valency will be satisfied by hydrogen. So this is the actual structure and this is the bond length structure. Okay? This is the bond length structure. Take the example of this C6 H6. Okay? So how should I write it now here? I'll write it like this. This is this. Now I will develop this one. So what I will write now here? C, 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 C. Okay. Now you have double bond. See here. Here, between all the carbon, how many bonds you have? 3. See here. Between this and this. Huh? See here. Between this and this. See, this one bond is here.
No.
Another bond and third bond. That is 4 minus 3 is what? Hydrogen. 1, 2, 3. 4 minus 3, 1. 1, 2, 3 is 1. 1, 2, 3, it is 1. 1, 2, 3, it is 1. 1, 2, 3.
What's wrong with you, huh?
This. So this is these are called bond length structures. So if the compound contains any other atom other than carbon and hydrogen, so those atoms you have to write. You have to write those atoms. Say you have taken C2H5OH. How to do is bond length structure? No problem. We'll write like this. This I have to write oxygen. Only in the carbon part I will not write any elements. See here now. So, for how to develop this one? COH. Now, what should I write it here? Here you find the valency is one. You have one bond. So I'll subtract this one from valency of 4. So 4 minus 1 is 3. So what should I write now here? I should write 1, 2. So this 4 minus 2. So this is the bond line structure, and this is the actual structure. This is the structural formula. This is the bond line formula. Okay. So now I have written here this. Don't get scared. You know what to do. I told you. Every places you put carbon. Here also you put carbon. Here also you put carbon. This, carbon. Then find the number of hydrogen by subtracting the bonds from there from 4. Right. Like this. আচ্ছা একটা কথা তোমার মরিচপুরে অতটা রাখবে রান্না বাকি যদি শুকায় বলি আবার ঢুকে রাখবে অত কিটা ওই বাড়ি ঢুকে যা আচ্ছা ঠিক আছে রাখি হ্যাঁ ঠিক আছে finished. So what will write down here? See, for this carbon, for this, write it here. See, for this is the this. For this is this. For this one, this. For this, this. Then for this one, C. Then we have OH. See now here. It is 4 minus 3. 4 minus 1. So it is 3. 1, 2. 4 minus 2. 2. See, this carbon. 4, 1, 2, 3, 4. 4 minus 4, 0. So no hydrogen for this carbon. This is 4 minus 1. This. See now it is 1, 2, 3. So 4 minus 3 is 1. So this is his structural formula. And this is his bond line formula. All right. C. 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 For this, C. 1, 2, 3 bonds. 1, 2, 3. So put it again here. Subtract 1 bond. So 4 minus 1, it is 3. 4, 1, 2, 3, 4. 4 minus 4 is 0. So this carbon does not have a hydrogen. 4 minus 1, 3. Don't I do double ta. If I find you, no, see, I'll break your head. This. See, 1, 2, 3, 4. So this carbon does not have hydrogen. This. So in this case, it will be so this is what? This is skeleton. So here, 1, 2. Here will be 2. Here also it will be 2. Here also it will be 2. Here also it will be 2. Okay? Now 1, 2, 3. 1, 2, 3, 4. Nothing. 1, 2, 3, 4. Nothing. See, 1, 2, 3. 4 minus 3 is 1. So it will be H. ভালো লিখবি কিন্তু না জিয়া
Yes, sir.
I told that write correctly.
Okay, sir.
এখন খাওয়ার পরে দিন রুটি 12টা 11টা 12টা থাকে নালে রাতে হয় না অ্যাম্বুলেন্স না
So now we know that organic molecules, their formula can be written in 3 different ways. One is the structural formula where everything is clear. You know what are the different atoms are there, how many bonds they do they have, what are the different elements are combined with each other directly with them. Then if the molecules are big, then we write in abbreviated form, and these are, we call it as condensed formula. And we write them also by using, if the compound, we can write it, it can express it even with their bonds. So we call them as the bond line structures. Clear? So after that, we'll go for nomenclature. Today, we call it word root. Okay. Before the main anything we write, we call it prefix. And after that, if you write, we call it suffix. Okay. Najia, tar pura naam ki?
So Nazia Akhtar.
Acha. So it is Nazia AKH. Correct spelling, Akhtar?
Yes, sir.
Acha. Then when you fill up the form, do you know right before that? Miss. Huh?
Maybe.
Hey, what maybe?
Yes, sir. Yes, sir.
You have maybe. See, but when your friend calls you, they will not call you by this. They will call it Nazia. What is her name? What is her name? Nazia Akhtar. It may happen you may be only called by this. All right. So in that case, it is our organic chemistry compound's name is also almost like this. It consists of 3 words. But as the molecules have become more and more complicated, so many things are being added to the main molecule. So we have to somehow do more changes in it. That is what did you do? We have made bifurcated prefixes into 2 prefixes, and suffixes are again bifurcated into 2 suffixes. So this is again being bifurcated into 2 prefixes. We call it secondary prefix. Very interesting. I should have started primary. No, I'll tell you why you have written that. Then what you have now here? Primary. No. Secondary prefix. Then we have here primary prefix. What do this remain same? What? Similarly, suffix is also being made into 2 parts. Primary suffix, and we put here secondary suffix. That is what I can write now here. I can write in abbreviated form. SP, PP, WR, PS, and it is SS. Now, why do you write secondary? Secondary should always come after primary. But why did you write like this? Just to avoid any confusion. See here, we make it symmetrical. Secondary, secondary. Primary, primary. It almost is it as if this is the mirror. mirror object, if the far in the mirror, reflection also comes far. If it is nearer, the reflection also is nearer. So this is being maintained written in such way to maintain symmetry. So the student should not undergo confusion. It will start with secondary, end with secondary. In between that, you will have primary on both sides. That is the one. Now this secondary prefix stands for what? Secondary prefix stands for substitution. This is substitution. What is primary prefix? We have come across there are some compounds which are cyclic in nature. So in that case, if it is cyclic, before the word root, I will write this word cyclo. Okay, now word root, see here. This word root evolves from the number of carbon atom the main chain has. Okay, it is derived from the number of carbon atoms the main chain has. Example, if it is one carbon atom, the name will be METH. 4 name we have derived from the classical name. ETH. Third carbon is Pro. 4 carbon is blue. This we have taken from our primitive name given, classical name. Okay. Then from 5 carbon onwards, it is named after the Roman multiples. Okay. 5 carbon will be pent. 6 carbon hex. 8 carbon oct. 9 carbon non. 10 carbon, we call it dec. If it is 11 carbon, we call it unidec. 12 carbon, dodec. 13 carbon, tridec. And like this.
Sir, there is no 7 carbon.
I did not write. Obviously, after hex will be heft. In that case, I have to write up to 70, dear.
Okay, sir.
I have written down because this is a little different. Unidec, dodec. Okay. Now, what is the suffix stands for? Suffix stands, if it is saturated, then we will write here N. If it contains double bond, then we write here, I'll write here this. In. If it is triple bond, we call it ein. Okay, this is for this. And if suffix is functional group. Functional group, always name will come after the main name. Functional group. That is, we can say almost we write our title after the name. Title means what? The clan to which we belong. So this. So next day I think for nomenclature I may have to take 2-3 classes.